An AI chief scientist says elite degrees no longer matter. Here's why. A little while ago, a chaired professor at Tsinghua University, think China's MIT, said something online that lit a match under the whole education system. He said getting into Tsinghua or Peking University barely matters anymore. For generations, that was the ultimate prize. The golden ticket every student, parent, and teacher obsessed over. And this guy, a top basic scientist who also runs a major AI research institute, just stood up and said it's not worth it. Because what those elite schools can give you now is far less than what a large language model can put in your hands. That's a wild claim. And the book behind it is called Artificial General Intelligence. It distills more than a decade of his thinking on AI. So today I want to walk you through it and answer two questions that should keep all of us up at night. In the age of general AI, what value is left that humans can't be replaced in? And how do you raise a kid or grow yourself in a world like that? Let's start with the big one. What actually is artificial general intelligence? The author maps it using two dimensions, environment and strategy, which gives you 4 quadrants. Quadrant 1, closed environment static strategy. This is an AI that runs on fixed rules inside a sealed-off world. Simple problems, terrible scalability. Quadrant 2, open environment static strategy. Old-school symbolic AI that tried to cram the messy real world into rigid logic, and it failed. The real world is just too complex and too dynamic. Quadrant 3, closed environment dynamic strategy. The rules are clear, but the situation keeps evolving. Think AlphaGo. Think full self-driving. And Quadrant 4, open environment dynamic strategy. An AI that, like a human, constantly adjusts its strategy in a chaotic, unpredictable world to figure out how to survive and thrive. That is artificial general intelligence. AGI. So the defining feature of AGI is this. When the world is volatile and unpredictable, it builds dynamic, self-adapting strategies to handle challenges that keep changing on it. Okay, so where does that intelligence actually come from? The book lays out 3 main paths. Path 1, imitate human behavior. In AI, this is called reinforcement learning. The AI tries things, gets rewarded or punished, and slowly optimizes. It's exactly how you learn to ride a bike as a kid: wobble, fall, adjust, succeed, repeat. Trial and error with feedback. Path 2, imitate the brain's neural machinery. This is neural networks and computational neuroscience. To these researchers, the essence of intelligence is learning, so they built artificial neural networks that mimic how the brain processes information. Through deep learning, the AI extracts patterns from massive amounts of data, all on its own. Path 3, imitate human cognition. This is natural language processing, and it's the path that gave us large language models. Unlike the first two, it doesn't just copy behavior or wiring. It captures the knowledge, the ideas, the cognitive structures embedded in human language. ChatGPT was the milestone here. It showed that through language and large-scale pre-training, AI could display something that looks a lot like general intelligence in an open world. Now, the part that actually applies to your life. In the age of AGI, what should you learn? The author names 5 core abilities: research, statistics, logic, psychology, and rhetoric. Research isn't about running experiments or writing papers. It's the ability to identify the real problem and ask the key question. A good question beats a correct answer. Statistics is how you find real signal in a flood of noise. Our problem today isn't too little information. It's too much, laced with garbage, manipulation, and AI-generated junk. You need to be able to pull the real variables out, see the structure, and build an accurate picture of the world. Logic is reasoning from first principles, starting from the root and building up new understanding step by step. Psychology is understanding yourself and others. Why are we working so hard? What's the point? With this, you develop your own judgment, and you stop being controlled by everyone else's opinion of you. And rhetoric is persuading others to act with you. If you want to serve the world, you have to unite people, and rhetoric is how you influence them and make collective action happen. Put those 5 together and you get a complete path. Research, statistics, and logic help you find truth. Psychology gives you inner freedom, and rhetoric lets you serve society, unite people, and drive change. I'd add one more the author didn't quite spell out. In the age of large models, knowing how to use a large model to learn effectively. That's the real reason he says Tsinghua and Peking University barely matter anymore. Because with a large model at your side, you can learn far faster than any traditional classroom can teach you. Now here's where I want to go off script and add my own take, because I work in this field, And I think the most fascinating story in AI isn't the technology. It's how the role of the human engineer has changed. Because if you watch that change, you can see exactly which skills are losing value and which ones are gaining it. Let me take you through 5 eras. Era 1. Feature engineering, roughly 1980 to 2011. Here the engineer's job was to tell the model what to look at. The models were traditional machine learning, a feature extractor up front, hand-designed by humans, feeding into a classifier. There was a classic saying, "Features matter more than algorithms." An entire profession was born, feature engineering, and through the 2000s it was the hottest field in machine learning. It's like teaching a kid to recognize an apple. You tell them, look at the color, the shape, the size. Engineers were hand-holding machines, telling them what to see. But as the tasks got more complex, hand-designing features hit a wall. Which led to a deeper question. Could the model learn to extract its own features? The answer was a paradigm called end-to-end learning, from raw pixels straight to the result, with everything in between learnable. And the architecture that won was the artificial neural network. Which brings us to Era 2, neural networks, 2012 to 2020. In 2012, 2 students of Geoffrey Hinton, the deep learning godfather who later won the 2024 Nobel Prize in Physics, trained an 8-layer network called AlexNet on 2 NVIDIA gaming GPUs and entered an image recognition contest. AlexNet's error rate was 15.3%, a full 10 points better than second place. And second place was still using handcrafted features. It was a curb stomp. It shocked the entire field. AlexNet proved one thing. With enough data and compute, a neural network learns better features than any human could design. The whole feature hierarchy just emerged on its own. The feature engineering era was over. But neural networks brought a new headache. Hyperparameters. Network depth, width, learning rate, batch size, the combinations are astronomical, and they make or break performance. So the engineer's job transformed. They stopped designing features and started tuning networks. People gave it a nickname, cooking alchemy. An engineer might spend 80% of their time just tuning, running experiment after experiment, hoping to stumble onto the best setup. So naturally someone asked, can we automate this? Around 2016 Google introduced neural architecture search, which evolved into AutoML, automated machine learning. And the alchemy started disappearing. But what really ended that era was the large model. Which brings us to Era 3, foundation models and prompt engineering, 2020 to 2023. In 2020, OpenAI released GPT-3. Turning point. These are called foundation models, already pre-trained, already incredibly capable. All that architecture design and tuning, no longer needed. The foundation model is like an insanely powerful engine. The only question now is how to get 100% out of it. And the key to that is giving it good information. People found that if your prompt is vague, the answer drifts. If your prompt is detailed and clear, the answer is sharp. So the prompt became everything and a new discipline appeared, prompt engineering. By early 2023, prompt engineer was a hot, high-paying job title. And then it died. Fast. Why? First, the models got smarter. Newer models don't need you to say, act as an expert, or think step by step. They just do it. The clever wording got automated away by the model itself. Second, prompt engineering couldn't fix the real bottleneck, the information problem. Back in 2020, a model could only handle around 1,000 tokens. By 2024, that jumped to 128,000. So now you can stuff in the whole conversation the entire knowledge base. But people quickly learned, longer context isn't always better. Models start to forget. Once you've used even 10% of the window, a problem called context rot. So the question shifted. It went from, how do I make the model understand with a little information, to, how do I make the model find the key point inside a mountain of information? And that gave us context engineering, recalling the most relevant content, compressing it, and organizing it so the critical stuff stays in focus. But then people hit the next limit. A large model can't actually do anything. It only generates text. If you need it to send an email, query a database, control a device, text alone is useless. And it can't see real-world feedback to adjust its plan. On top of that, its knowledge is frozen at its training cutoff, so for anything live or current, it just confidently hallucinates. So the model is passive, static, and limited. And to fix that, agents were born. Era 4. Agent engineering, 2023 to 2025. An agent can call external tools and APIs. Through that virtual hand, it reaches out to live data sources, grounding the model in reality so it stops relying on hallucinations. And instead of spitting out one answer and stopping, an agent runs a loop. Reason, decide what it needs, call a tool, observe the result, update, keep going. So agent engineers design the decision-making skeleton, how the agent breaks a goal into subtasks, which tools it can use, and how its memory works, what it remembers, what it forgets when it recalls. But agents created new problems. What happens when an API times out? How do you tell if the agent is actually making progress or just spinning in circles? And when it makes a mistake, how do you stop that mistake from repeating in every future session? People realized that giving an agent initiative isn't enough. Without a framework to guide that initiative, the initiative just becomes chaos. Which brings us to Era 5, the one happening right now, that most people don't even know about yet, Harness Engineering and System Governance 2026 onward. In February 2026, HashiCorp co-founder Mitchell Hashimoto coined the term harness engineering. A harness is literally the reins and saddle you put on a horse. A powerful horse can run fast, but without the reins it runs anywhere. The harness channels that power in the right direction. With an agent, the whole pipeline of calling the model is automated, which means it's prone to errors, hallucinations, and going off the rails. The harness is the control system you strap onto it. The core innovation here is a clear, persistent, evolving rulebook that gets injected before every single model call: goals, hard constraints, role definitions, capability boundaries. These files live in a code repository, version-controlled and traceable. And every time the agent screws up, the rule file gets updated so that mistake never happens again in any future session. So the harness engineer's craft is writing the rulebook, defining input-output specs, designing when tools get triggered, building feedback loops that autocorrect errors, and orchestrating so all the steps run in sync. Now step back and look at all 5 eras together, because 2 powerful patterns emerge. The first pattern, the cycle of innovation and bottleneck. Every AI upgrade massively boosts performance and wipes out a category of work. But it also creates a new bottleneck, and the human engineer's job shifts to solving that bottleneck. And a new kind of engineering is born. It's exactly like cars replacing horse-drawn carriages. Cars destroyed the coachman's job, but they created new ones. Mechanics, car designers, road infrastructure, traffic management, gas stations, dealerships. The problems moved up a level, and so did the work. The second pattern, the upward migration of human tasks. Every AI advance pushes humans up, from micro-level detail decisions to macro-level framework design, from low-level specifics to high-level strategic steering. Automate one layer, and you unlock the problem space of the layer above it. In the feature era, the human told the model what to see. In the hyperparameter era, the human optimized the model itself. In the prompt era, the model was strong enough that the human's job was to feed it the best information. In the agent era, the human designed the decision skeleton. And in the harness era, the human defines the operating framework, the goals, the constraints that keep the whole thing running smoothly. Here's a way to picture it. Think of the AI as an employee at a company, and the human as a manager with a technical background. If the employee is weak, the manager has to roll up their sleeves and do part of the hard work themselves. That's feature engineering. But if the employee is strong, the manager stops micromanaging the details. Instead, they give them better information, prompt and context engineering. They build a better environment, agent engineering. And they handle how this person fits into the whole operation and steer the big picture direction, harness engineering. And being that manager takes completely different skills than doing the work yourself. The higher you go, the more total system complexity you have to manage. More complex systems demand more sophisticated constraints, the ability to find the right goal, judgment, taste, and decisiveness at the critical moment. So what does this mean for you and me? Across both patterns, one trend is unmistakable. As low-level execution skills get automated away, the demand for higher-dimension strategic skills goes up. Every upgrade devalues the old execution skills but raises the demand for strategic thinking. The feature engineer had to understand data. Hyperparameter tuning meant understanding the model. Prompting meant understanding intent. Agent design meant understanding systems. Harness engineering means understanding the constraints and risks of the entire pipeline. Every level up, the abstraction and the big picture view you need multiplies, which means pure execution skill is being devalued, and decision-making and systems thinking are appreciating. So if you're a computer science student, maybe don't pour everything into learning the newest framework, the slickest coding tricks, the most cutting-edge architecture, because the half-life of that knowledge keeps shrinking. AI is taking over the work that's well-defined, quantifiable, and automatable. It will catch up to you at the execution layer faster than you can imagine. More and more of the future's work will require humans operating at a higher level of abstraction. You can't just understand how one module works, you have to understand how all the parts of the system interact, balance, and constrain each other. Here's the way I'd put it. As you drill down, you have to keep climbing up. Drilling down means mastering one specific technical domain to the extreme: CUDA programming, chip design, deep learning frameworks. That work is competitive, but its competitive half-life is shrinking. Climbing up means constantly raising your level of abstraction, from an engineer who writes code, to an architect who designs systems, to a strategist who understands the direction of the whole organization. This doesn't mean fundamentals stop mattering. The opposite: the higher you climb, the more they matter because your decisions affect more and more people's work. But the center of gravity of knowledge is moving up. So how do you build this kind of thinking? 3 things. First, get more exposure to full-stack projects. Not that everyone needs to be a full-stack developer, but you need the experience of the whole pipeline: data, training, integration, risk control. That's the only way you understand why some inelegant design is actually safer, and why some constraint that looks limiting is actually protecting the whole system. Second, shift from "how do I do it" to "why do it this way" and "what should be done." The skill humans need isn't just problem solving, it's problem defining. When AI can solve most well-defined problems faster than you, the human value becomes defining the right problem, spotting the hidden assumptions, and finding the true key point in the problem space. That's a completely different kind of training. Not "give me a problem and I'll pick an algorithm," but is the problem really defined this way? Is there another angle? Does the metric I'm optimizing actually match the outcome I want? Third, understand the philosophy and principles behind the knowledge, because understanding why beats memorizing details. A student doesn't need to memorize every PyTorch API, but they need to understand the philosophy of how the framework is designed. Knowledge updates. Design principles are stable. You don't need to hand-build a compiler, but you need to understand how compilers work. Now someone might ask, in the future, won't AI itself develop decision-making and systems thinking, these strategic skills? In my analogy, the AI is the employee and the human is the technical manager. But if AI keeps advancing, why wouldn't it become the manager and we become the employees? Here's the fundamental concept you have to grasp. Training any AI model starts with setting a clear optimization goal. Once the goal is set, training begins, and training is, at its core, just endlessly adjusting internal parameters to best achieve that goal. But here's the key. That goal is defined by a human. Someone is setting the AI's objective, defining what's good, what's bad, which metrics matter, which don't, making all the trade-offs. These look like technical decisions, but they actually contain human judgment, human taste, human values at the deepest level. And that is the thickest moat humans have in the age of intelligence. So when that professor says getting into an elite university barely matters anymore, this is what he's really pointing at. The skills that used to define a top education, absorbing and executing knowledge, are exactly the skills AI is automating. What can't be automated is the judgment to define the right goal, the taste to know what's worth building, and the values that decide what good even means. That's the takeaway I want to leave you with. Don't compete with AI at execution. You'll lose. Climb up. Become the person who decides what's worth doing in the first place. That's the value no model can take from you. If this resonated, drop a like and subscribe. I'll see you in the next one.